So yesterday we went over, on your notes, we went over I think 5 words here, or 6 words. We went over parent function. We went over 4 kinds of transformations. The first kind of transformation, go ahead and put number 1 next to it. Gentlemen, please. The first kind of transformation, go ahead and put a 1 next to it on translation. The second kind on reflection, go ahead and put a 2 on it. Vertical stretch, go ahead and put a 3. And then vertical shrink, put a 4. The reason why I want you to number them is because I want you to understand you only have 4 to choose from right now. Only 4 kinds of transformations. So let's try that again here. So we have transformation. There's 4 kinds of them. The first one is a translation, put number 1. Remember, that's just a fancy word for a slide. Again, if you're absent yesterday, you'll fill all this stuff up later with the video I already posted later.
I have paper.
Number 2 is a reflection. I got you. Number 3 is vertical stretch. Translation is the first kind of transformation. So these 4 are different kinds of transformations. Okay? So let me get right now, phones away. No fiddling with the phones during the lecture time. All right. Now, let's do this. Go ahead and flip the page now. Flip the page. So on the first example on the back, let's go ahead and do this here. So number 1, let's look at the mission. It says, identify the function family to which f belongs. Now f is just the name of the function. Look at f. Remember, f of x, that little f is just the name of the function. It can be g of x, h of x. So they're saying, look, that function, f of x, what's the family it belongs to? That's a mission number 1. And then it says, compare the graph of compare the graph of f to the graph of its parent. So we're doing 2 things. First, figuring out what family it's in. Secondly, what kind of transformation took place. Watch this. Just by looking at this, what would be the parent here out of the 4? This is definitely a linear. It's a line and there's a slant to it. It's linear. So look what I'm going to do on my desmos.com, which you're going to use later on today, on my graphing calculator. I'm going to go ahead and graph the parent function. On your notes at the bottom on the other side, the parent function for linear, watch this, I'm going to put it in here, f of x equals x. Look at that. There's a parent. And you already have a picture of this on the other side at the bottom. Now, how does a parent compare to the child? Look at this. There's the child. How do we go from the parent to the child is the question. But before we even answer that, let's go ahead and write the family that Miss Betty already told us. So go ahead and write linear. This is a linear function, L-I-N-A-R. I'm going to do that. So this is the linear family. That's mission 1, the linear family. Mission 2. How did we get from the parent to this? Watch what happened. Look at this. If I put a negative in front of the x, it'll end up reflecting the whole graph. In other words, everything up here will be on the other side of the x-axis, and everything down here will be on the other side of the x-axis, so it'll be heading downwards. In other words, it'll be like a flip. This will be at the bottom, this will be at the top, just by putting a negative symbol. Watch this. So a negative symbol reflects it. Notice. Just that negative symbol reflected over the x-axis. Which is why, when we look at number 1, it's going down. The parent goes up. Now this is going down. Well, that's because there's a negative there. The negative makes it go down. So the first thing we know that took place from the parent to the child is, write this down with me, is a reflection. Reflection over x-axis. The x-axis kind of served like a mirror. First bullet. So right now we're comparing this graph to the parent. The first thing is it's going down, which means there's a reflection. First thing. Now, the second thing, it doesn't seem as steep. Let me go back to the parent. Look at the parent. This is pretty steep. If I reflect it, watch this. If I reflect it, well, here's a parent. I reflect it, but I look at the child. The child is not as steep. The parent is very steep. The child is not as steep. So something took place. It went from steepness to kind of not as steep. That's because of the coefficient of x is actually a fraction. What ended up happening is, if I smash the line, imagine me smashing the line's going to get less steep. It's going to come up like this. A vertical shrink will take place. If I smash the line, it's going to get less steep. Watch. Look at when I put 1/4 in front of the x. Watch when I put 1/4. 1/4, now it's less steep. So yesterday, there was two kinds of stretches or vertical transformations. One was a stretch, right here, number 3, and one was a shrink. You know it's a shrink if the coefficient, that means the number in front of the variable, is a fraction. We went over that yesterday. And you know it's a stretch if the coefficient is bigger than 1, which is the whole number. So if it's bigger than 1, you're going to stretch that graph. If it's less than 1 but greater than 0, which is a fraction, it's going to be a smash, a vertical shrink, which is exactly what took place. Notice, I took the line and I shrunk it. That's why it's less steep. So let's go back to the notes. Number 1, we already have a reflection. The second thing now is, put another bullet, vertical shrink. Because of the 1/4 coefficient. Vertical shrink. Okay. So we got the reflection, vertical shrink, but not only that, I noticed that the line, look at the parent. The parent is actually crossing at 0. The child is way up here at 8. The child went all the way up here at 8. Notice your notes. It's all the way up here at 8. So what kind of transformation would that be? Is it a translation, is it a reflection, or is it a shrink, or stretch? The line went from 0 all the way up. What would that be called? Translation. Look at what I'm going to do. I'm going to put +8. Look at up here. I'll put +8. Look at how the line goes up. +8, and it's up there. There it is. So it's a translation, 8 units upward. Write that down with me. Here we go. And we're done with number 1. Going to put translation. We're not going to say slide. We're going to use the right word. Translation, upward, 8 units. Reyes, we're good? Yeah. This is math 3, man. It's getting complex. You got to start getting some notes down, dude. Seriously. Number 2. What family does that puppy belong to? It's a horizontal line, straight, no slant. Can someone tell me the family? Constant. Go right, constant. Remember, there's only 4 to choose from. All right. Now, how does that child compare with the constant's parent? If I look at the constant's parent, it looks like this. Look on the other side, on the bottom. The constant's parent is a horizontal line at 1. Actually, here's 1. Here's the constant's parent right here. What would it be, Gonzalez? I thought I heard you say it. Go ahead. Right. What kind? What kind of transformation, though? Translation. We went down 1, 2, 3, 4 units. Here's the parent. And now the child is a translation. That's a slide down 4 units. Okay, 1, 2, 3, 4. So that's how we're going to describe the transformation. Go to right. translation, 4 units downward. Translation, 4 units downward. And the family was constant. Rocking and rolling. Number 3. Via, what would be the family for number 3? Go to write absolute value. I'll put this one in green. Absolute, I'll abbreviate ABS, value. This is an absolute value family. So how does the child compare with the parent? If you look at the parent on the other side, the parent looks like this. It goes to the origin. This part goes that way, and this part goes that way. What the heck took place? It's a vertical stretch. Notice the coefficient of x now. Think of vertical stretches. Yeah, here we go. Well, yeah, we'll do that after, when I'm done. Okay, here we go. I'm explaining it right now. Thank you, Medina. Here we go. Vertical stretch, notice y from yesterday. When a coefficient of x is greater than 1, that's exactly what we got going on right now. Look at the coefficient is greater than 1. It's actually a 5. Notice, it's 5. So it's going to stretch. I'm taking the parent in blue, and I stretch it out. Let me demonstrate with the graphing calculator one more time. Look at this. Let me go ahead and put f of x, and put the parent function of absolute value. By the way, to get absolute value, hit this button, and there's the absolute value symbol. Let me put x. Let me close it. There's the parent. Now look at if I put the coefficient of 5. Watch this. Let me copy, paste this puppy. But let me put a coefficient of 5. Watch the parent now and the child. I'll put a 5. There it is. I vertically stretched the parent. Now it's skinnier. All right, so let's go ahead and describe this puppy. So what took place? We got a vertical stretch. Go and write that down. Vertical stretch. Remember, there's only 4 to choose from. It's either reflection, translation, vertical stretch, or vertical shrink. Let's try number 4. Chang, what kind of family is number 4? There's 4 to choose from. Look in the back. Which one does it look like? Quadratic? All right. All right. Here we go. So the parent looks like this. Hold on. So Gonzalez, you said it. Go ahead.
4 units into the right, 1 unit.
A transformation, you said? Translation. So look at. Here's the parent. Look at the parent. I'll draw the parent as best I can in red. So look at what happened to the parent. The parent, if you look on the other side at the bottom, the parent function, look at this, f of x equals x squared. What's the coefficient of the parent, x? Can anybody tell me what the coefficient here is? 1. What's the coefficient of the child? 1. It's still 1. So there's no stretches or shrinks. If you see a coefficient in front of x change, then you know you're either dealing with a stretch or a shrink. But there is no stretch or shrink at all. But there is movement, and Mr. Gonzalez got it. Look at, there's 4 units up. Look at 2. Let me move my red. There's 2, 4 units up. That's a translation. The slide up 4 units, and then 1 unit to the right. Perfect. Let's write that down. Translation. Here we go. Write it down. 4 units upward and 2 units. Actually, and 1 unit rather. And 1 unit to the right. Translation 4 units upward and 1 unit to the right. Yeah, here we go. Last 3. Questions so far? Here we go. I'm going to go a little quicker now. Last 3. It says graph the function and its parent function, then describe the transformation. So here, it's asking us to graph. What I want you to do when you get to assignment 3 is actually use a graphing calculator. I want you to cheat a little bit. I don't want you to make any table of values. Just punch the child in. Watch this. Let me punch the child in. F of x equals x minus 7. Watch this. X minus 7. There's a child. This is linear, so let me go ahead and punch in the parent now. F of x. I can just copy and paste to go quicker. Copy. There's a parent in green. Parent, child. If you forget what the parents look like or what the equations are, just look at the bottom. It tells you what the parent functions look like. This is a parent of a linear. Now, let's compare. What the heck happened? This is number 5. So what took place from the green to the red? Translation, how many units? 7 units down. There's our answer. So let me go ahead and graph those puppies. Watch this. The parent, let's do a rough graph. Here's a parent, and here was a child. That's 7. Look at. Do that with me. Again, I just copied this from my graphing calculator. I'm not doing anything fancy schmancy. I just punch them in, and I'm copying them from the graphing calculator, which is what I want you to do for assignment 3. Use desmos.com. So again, this was a translation from the parent to the child. Well, that's a parent, huh? That's a child, so it went down. Right? You always start from the parent. Translation, 7 units down. We're rocking and rolling. Questions so far? Number 6. Let me punch that puppy in. F of x equals 9, or negative 9. Watch this. F of x equals negative 9. And so let's see, where is negative 9? There it is. It's at the bottom. Okay, it's a horizontal line, so I know it's part of the constant family. Let me go ahead and type in the parent now. F of x equals 1. So it's a horizontal line right at 1 versus a horizontal line at negative 9. Let me graph those. So here's f of x equals negative 9, f of x equals 1. Coming back over here, let me draw them. Doesn't have to be a Picasso drawing. We're going by 2, so look at, here's a parent, f of x equals 1. And the child in red, f of x equals 9. Someone besides Gonzalez. What took place from the parent to the child? Thanks, guys. How many? 9. Close. You're close. Someone besides Gonzalez. Someone besides Torres. You're there. Check it out. Look at Padilla. We had the 9, but it's a little bit above the x-axis, so it's actually a total of 10 units down. It's 1 and plus a 9 more. So it's translated 10 units down. I'm going to write that down. Translation, 10 units down. Rocking and rolling. So you always start from the parent, and then you ask yourself, how did the child get to where it's at in comparison with the parent? That's it. Let's do the last one. I'll do it quickly. Number 7. F of x equals x, absolute value of x plus 1. Absolute value, absolute value of x plus 1. What a fool. Plus 1. All right, there's a parent in red. And here's a child. Let me copy and paste this puppy. All right, so the parent's green, child's red. Parent is green, child's red. So let me draw those puppies real quick. So parent is green, child is red.
Would you say you go to parent and child or child? Which do you start off from?
What comes first in nature? So parent's green, child's red. What the heck took place here? How many units?
1.
It's actually 1. I messed up. You're right. It's 1. Right there. It should be right there. Because they're going by 2s.
1 up.
1 up. And this tells you it's 1 up. Look at the +1.
Uh-huh.
Was it?